So now that we've kind of defined what ecosystems are and the types of ecosystems that are out there, now we can look at how energy flows through an ecosystem. Now the steps of an ecosystem energy flow are called the trophic levels. Trophic, we think eating. So we're basically looking at who's eating who and how that energy is moving through those different levels. Now the Earth is constantly provided with energy from the sun, but only about 1% of the incoming energy is ever converted by plants during photosynthesis. So this is also another reason why solar energy would be fantastic as a renewable resource, because there's a lot of it available, a lot of energy available, and only 1% is getting captured by those plants. Remember that the plants, algae, and cyanobacteria are photosynthetic, meaning they're going to be producing their own nutrients. They're going to take inorganic molecules and make organic ones. This puts them in the category of producers, meaning they're converting light energy into chemical energy stored in organic chemical bonds. So those producers are taking in that carbon dioxide as well as water and using light energy to convert those into things like glucose and oxygen gas. Now the amount of organic material produced in a biome is called the primary productivity. So some biomes are going to be very productive and others will be less productive. Now when we say productive, we don't necessarily mean that it's more successful. We're just simply talking about how much of that organic material it produces. So don't take that productivity as meaning that it's more successful. We're not necessarily talking about that. So let's go ahead and look at how energy flows within an ecosystem and then look at some more complex things building off of that idea. So the energy starts with the sun, it gets intercepted by the producers and converted into chemical energy through the process of photosynthesis. Now, producers are not the only organisms. We learned about the heterotrophs in the last unit, where we talked about herbivores and we talked about fungi and animals. And so the primary consumers are going to be the herbivore animals that eat plants. But not every animal eats plants. Some of them eat other animals, and that's where we get to secondary consumers. So these are the carnivores that eat the herbivores. And then the tertiary consumers are the top carnivores that eat other carnivores as well as maybe other herbivores. Now, so we see this chain of from producers to primary consumers to secondary and tertiary consumers. And as we notice, this arrow is getting smaller every single time we go up a level. So a lot of the energy that we're carrying from the sun to the plants, from the plants to the herbivores, from the herbivores to the carnivores and so on, is not going to be fully used to its capacity. We're going to lose, quote, lose some energy in the form of things like heat. Now, is it always this nice linear line? Not always. This is where we can look at a food web. So this is more like a food chain where we're going from one level to the next, to the next, to the next. But in reality, this tertiary consumer might eat the snake, but it also might eat this gopher. And so a food web is a better representation because a single organism can represent more than one position. So for example, we look at this ground squirrel of some sort, and he's eating the plants, but he's also eating insects. So we see that the energy is flowing in the direction of the arrows. So basically, the arrow is pointing to whoever's eating that organism. So the grass is getting eaten by this guy, this rodent, and then he's getting eaten by this snake. But we see that this tertiary consumer is not just eating the secondary consumers like the food chain showed us. He's also eating the primary consumer. So the food chain shows energy flow through an ecosystem, but again, the food chain is really simple. The food web is a more accurate representation of all these different trophic levels because it shows that a lot of times organisms can be omnivores, meaning they're eating both plants and animals. So they're not truly a carnivore completely, and they're not truly an herbivore. And so you can occupy multiple trophic levels in an ecosystem. Think of ourselves, right? When you go and you eat, you don't strictly eat steak and nothing else. You have probably vegetables on the side. Maybe one day you go vegetarian and another day you decide to go on a meat-eating spree, right? We're omnivores. We're a really good example of that. We're also not looking at the decomposers here. Now, the decomposers that are usually fungi or bacteria are extremely important, along with the detritivores like worms, arthropods, and vultures. These guys are extremely important because they're going to help cycle things back around. So the molecules that are stored away in dead organisms, if nothing ate them, if nothing broke them down, those molecules would be stuck in those dead organisms forever. And when we see the word detritus, so like detritivores, we're looking at dead organisms. So you're going to try to maybe construct your own food web. We'll talk about this again a little bit later, or at least in an assignment or a discussion, looking at how these food chains or how these food webs really can be structured. Now, I had mentioned it earlier on the slide before that arrow was getting smaller for every level you're moving up, and that's because not all of the energy stored in an organism can be used. Only about 10% of the energy is going to be used for growth in the organism who ate it. And so the passage from food to feeder represents about a 90% energy loss. Now, keep in mind when we say loss, we don't mean that energy is destroyed. We simply mean that energy gets put into a form that is not really usable for the organism's growth. So this is really what's limiting the length of the food chains and why top predators are so rare. Because if you are a top predator, you are eating organisms at a level that have already basically lost energy multiple times throughout, and you're only going to extract about 10% of that. There's not enough energy basically for you to capture. And so there's not a lot of top predators around, simply because the energy loss from start to finish is so significant. You're only getting like 1% or so of that starting energy, right? You're getting a fraction of a percent of the energy that you started with at the producer level by the time you make it to the top predator level. Now, the total weight of living or non-living organic matter in a given volume, so we're looking at all the organic matter, whether it's from the dead, whether it's from the living, just in general, in a given volume, is called the biomass. And so we're looking at basically how much biomass is required to maintain something. So we look at like a 700 kilogram cow requires 7,000 kilograms of food. That's 10 times the weight of the cow. And this is one of the reasons why you see a push for plant-based diets for humans, because that amount of energy that we lose going from the producer to the primary consumer to us, we're losing a lot of energy, and we're having to use a lot of food to create the primary consumers we're trying to consume for ourselves. So this is why you do see a push for things like plant-based diets, because it is much more sustainable and doesn't require nearly as much food, right? For someone like us, if we were eating the same amount of food, the kilograms we would need to eat, the kilograms we would need to have a plant-based diet would be much, much lower than the biomass or the kilograms we would need to have a meat-based diet. So we can look at an energy pyramid kind of representing the biomass for the trophic levels of an ecosystem and what can be supported. So if there's 5,000 kilograms of plant matter, how much of that mass can be used by each trophic level for growth? From the producer level to the primary consumer level, only about 500 kilograms can be used for growth. So you're looking at, of the 5,000 kilograms of plant, you're only going to get 500 kilograms of primary consumer. And so then to support the secondary consumer from that 500 kilograms of the primary, you're only getting about 50. And by the time you get to the tertiary, you're only getting 5 kilograms. So you're losing a lot of biomass for every trophic level you go up, simply because we already know 90% of that energy is going to be gone. We're not going to be able to utilize that to grow and develop. Now, there's two basic things for life that we need: the building blocks, the basic supplies basically, and the energy to put them together. There's a finite number of atoms on Earth, but we haven't used up that finite number of atoms because we can recycle them. We call this nutrient cycling. We're going to get into nutrient cycling in the next video though. So just again, keep this in mind. We just went over how energy flows in the ecosystem, and it kind of makes you think about what you're consuming and how much has to go behind the production of the food that we consume, especially looking at things like herbivore or vegetarian options versus those that have meat. But before we go, we're going to look at this energy pyramid just as a visual before we go into the next video. Again, it's a 10% rule, so only about 10% of the biomass from each level is going to be converted into biomass for the next trophic level. So we start with the producers, and we see that only 10% from the producers is going to lead to primary consumers. Only 10% of the primary consumers will lead to secondary, and then only 10% of that gets to the tertiary consumers. So this is a lot of loss, right, when we transfer the energy from one level to the next. So keep that in mind. Again, like I said just a little while ago, keep that in mind when thinking about what goes into the production of the food that we consume and how much energy has to be put into, or how many resources have to be put into developing that food source.